702 and Cape Talk.
The Naked Scientist.
Chris, lovely to chat to you. Welcome. The whole world is on tenterhooks. We're all concerned about Ebola. What's the latest?
Yes, good morning. Really good morning, everybody. Well, it's certainly a worry, isn't it? We're seeing numbers climbing. We're seeing reports of spread of the cases being picked up in other countries, including Germany, Spain, potentially Australia. There's a nurse been isolated in Queensland in Australia, having been working in West Africa. She's returned home and now developed a fever. The gentleman who flew into Dallas in America has now died. And even the woman who is infected in Spain, the nurse who was caring for somebody who was infected with Ebola, even her dog has been put down. So now everyone's concerned what's actually going on. Well, at the moment, what people are now beginning to do is to debate how we actually try and contain the outbreak. We've got governments at high levels in many countries who are saying, well, do we need to have some kind of controls over who flies where, who flies into countries? And that may help a little bit, but there's a big problem here, which is it would be much better to try to stop the disease spreading out of the countries where it is in the first place. Because in my view, and many other people's views, when a person is already in another country and infected with Ebola, trying to stop them at that point is like slamming the door after the horse has bolted. It would be much better to stop people leaving with the infection in the first place, and even better to stop them getting the infection in the first place. The issue here is that the incubation period is very long. It's maybe 3 weeks in length. And when a person is in the early stages of developing this infection, or any other infection really, they may not have any symptoms whatsoever. So it's very difficult to know what sort of screening could be done in order to defend very effectively against that, apart from perhaps to profile where people have travelled from and to, and see whether or not you can stratify people into high-risk individuals who have come from a risk area and lower-risk individuals. But you can't possibly isolate every air passenger for 3 weeks. It just doesn't seem to work. So I'm not really sure what's going to be the outcome of this, whether or not they will be able to put in place some kind of screening that will really be effective.
And what about, I know there's so many questions to ask about this, but when there was that debate about the dog being put down, I heard one commentator saying there is no scientific evidence. There's no evidence that the dog could carry the Ebola virus. And I suppose the question is about the transmission of Ebola, the human to animal interaction. Do we have any information about it?
Well, the evidence that I've seen is that dogs that have been tested in the past, so there's historical data, and dogs have been found to have antibodies to Ebola. Now, that can mean one of two things. One, it can mean that the dog has been infected with Ebola at some point and has cleared the infection. It could also mean that the dog has merely been exposed to the Ebola agent but not necessarily infected, and they're not the same thing, because you can be exposed to something in the same way that you can be vaccinated against something that doesn't make you sick but it makes your immune system respond to that thing. The dogs may therefore never have had Ebola as an infection, so they may never actually pose a threat. We just don't know the answer to that. And then there's sort of a third question, which is if a dog does get Ebola, well, does that mean the dog can pass it on to a person? Or any other animal for that matter? We just don't know.
702 and Cape Talk. Reedy's on Twitter at Reedy Krabi.
Sadly, we have not been able to connect with the Naked Scientist, and from what Thomas tells me, it seems he thought he was still on air, and he continued to answer that question that we had asked. So what's basically going to happen is I will reintroduce Chris as soon as we have him on the line, and then we will take your questions then. Chris, are you with us?
Yes, hello.
Oh, we lost you at a very important part of your answer.
The only problem is I don't know when. I said a load, and then I discovered I wasn't there anymore.
All right, we'll just carry on because there are people who've been holding on for you on 021 446 0567 or 118883 0702. Anne in Vereniging, hi.
Good morning. Chris. Hello.
Carry on, Anne. You're live on air.
Sorry, I am a whitey and I need a hair transplant, and I've got a good friend, Gracie, who is black, who has offered me some of her hair. Would it grow on my head, and if so, would it be straight or curly?
Okay, would black hair grow on her? Yeah?
Well, it might take. The problem is that the cells in the hair follicle that grow the hair are going to be Gracie's hair and Gracie's cells, and therefore they're going to be recognised as different by the immune system, which means that they might take initially, but then the immune system might get rid of them. The answer to the second part of your question, in terms of, well, what would the texture of the hair be? The cells that are making the hair would be your donor's cells. And therefore, those cells would follow the genetic program written into them that tells them how to make hair in terms of what colour it should be and what texture, shape and twist it should have. And so if she has curly hair and she donates you some hair, you will get curly hair because it's her hair growing out of your head, using her cells until the immune system deals with it, obviously. So it's probably better to see if you can move some hair from other bits of your body, or have a chat to someone who, if you don't want curly hair, have a chat to someone who has straight hair. Mm-hmm. It's very kind of her to offer you a donation. How lovely.
Very, very lovely indeed. Let's go to Steve in Bantry Bay. Hi.
Hi, thanks for taking my call. I've got a bit of a problem. Most timber nowadays, roofing timber in particular, has been treated with insecticides to prevent borer beetle and so forth. Now, a lot of companies actually manufacture compost made from the sawdust of that timber. Now, I'm wondering if you use that sawdust, if it's been treated, for instance, with arsenic, because some of these insecticides they treat borer beetle with have got an arsenic base. If you plant your vegetables into that sawdust, will the vegetables be contaminated with that poison? Would it be safe to eat vegetables?
Hello, Steve. Well, you raise a really important point, and I would be very dubious, you're right, because if the chemicals that have been impregnated into the wood to act as fungicides and insecticides, if they don't break down in the composting process, then they will end up in the soil, and they may well leach chemicals that could be taken up into plants that you might then eat. It would be very worthwhile making that inquiry to the people who make the sawdust and the people who make the compost from the sawdust. Some of these compounds are safe, some of these compounds are made by plants themselves, and they're concentrated, or versions of them are synthetically produced, but they're pretty similar to the natural thing, and therefore they don't pose a threat because there are mechanisms in the soil to make them break down naturally. It's more likely, though, that synthetic things with a very long, what we call half-life, a long time in the environment so that they work for a long time, are being used, and they could pose a threat. They may pose none, but I would be dubious, and I think you're asking all the right questions. It's a really good point. It's a really important point, and I would approach the manufacturer and ask for clarification on that.
Let's go to Sean in Westcliff. Hi.
Good morning, Rudy, and good morning, Chris. One quick question. Bar of soap that you normally wash yourself with, when it gets to very, very thin, it seems to lather a hell of a lot less than what it did when you opened up the packet. I'll listen to your response on the radio. Thank you.
Mm-hmm. Hi, Sean. I can only think, and I know what you mean, that there's a number of aspects to this. One is the surface area of the soap, because when you've got a nice big bar of soap, there's a lot of surface. So when you rub it round on your hands, you're bringing your skin into contact with a lot of soap surface, and therefore a lot of soap molecules can come off, get onto your hand, and can make the lather. When the soap piece or fragment is much smaller, then there's less surface area, so it's harder for soap molecules to come off the soap and get onto your skin. So that might be part of it. The other part of it is that as it shrinks down, that there may be things that are soluble in the soap which have worked their way out every time you've made it wet and used it, so you're left with the less soluble remnants of the soap as you get towards the smaller husk in the middle, and therefore they come off less easily because chemically they're coming off less easily because they're less soluble, and therefore you make less lather for that reason too. So I think there's probably two effects going on there.
Thank you very much. And who came in first? On 021 446 0567 or 011 883 0702. Abigail in Somerset West. Hi.
Hi there, yes. I just want to ask a quick question. What causes you to sneeze when you look up towards the sunlight or anything?
Okay, your line is really, really bad. We can't continue with that. But I believe the question, Chris, is why do you sneeze when you look into the sun? I don't remember experiencing that, but that's what Abigail wanted to ask.
Oh, I do. And I guarantee that roughly one person in 5 listening to this programme will have had the photic sneeze reflex, which is exactly what Abigail is describing. As I say, affects about 20% of adults, and it seems to run in families, so it seems to be something which is genetically programmed, and scientists believe it's because of wiring in your nervous system. They used to think, or one theory of this was that when you looked at bright lights, that this made your eyes water a bit, and that when your eyes watered a bit, the tears ran down inside your nose, tickled your nose, and made you sneeze. But subsequent studies, including by the US Air Force, who are interested in this because obviously if you're employing a pilot to fly an aeroplane at 1,000 kilometres an hour and they start having a sneezing fit whenever they fly near the sun or towards the sun, this could have devastating effects. So you want to understand this. They concluded that the sneezing happens too quickly for it to be down to tears running down into the nose, and they therefore think that there is some cross-wiring in the part of the nervous system where the pupil size is controlled. When you look at a bright light, your pupil shrinks down to limit the amount of light going into your eye so you're not blinded. This part of the brain where this is encoded is also the same part of the brain where there are circuits that control your respiratory system and encode sneezing reflexes and tickle responses from your face and nose. So they think that in a small proportion of people, that when you trigger the pupil to become very small in response to bright light, it also tickles the same centres in the brainstem that decode and respond to tickling in your nose and trigger a sneeze, and therefore you sneeze in response to bright light when you're not accustomed to it.
Okay, let's go to Johnny. Johnny in Easterus. Good morning.
Hi, Rudy. Hi, Chris. Chris, the other morning I switched on the radio when Rudy was on, but then I dozed off. And then immediately...
Thanks, Johnny.
There you go, Rudy.
Then immediately that external information formed into a dream in my mind. And now my question is it the mind that converts that external information, or is it the brain itself with its synapses?
Right, okay. Yeah, I do. What I would suggest is that what's happening is that when you are in that state of a near wakefulness, so you're not quite awake but you're not quite asleep, you're dozing, your brain hasn't completely shut itself off from external stimuli. And the circuits that decode these external stimuli can nonetheless decode things like bits of conversation, other stimuli, sounds, and they will then trigger other regions of the brain, including the visual centres and some of the memory centres, into action. And memories will be called up or will be summoned or triggered, and experiences will be triggered in the other parts of the brain which are in that almost dreamlike state. And that's why you can literally find funny things that are happening to you coming into your dream, or you can sort of start having a conversation with someone and say really daft things, but you're still responding to them because you're still hearing things, but the other parts of your brain are on the way towards going to sleep. So you've got a little bit of disconnection going on between consciousness and unconsciousness, and I suspect that's what happens. It occasionally happens to me as well.
Thank you very much then, Johnny. I hope you don't fall asleep today, hey?
Bye.
Bye-bye.
Not during this programme.
No, of course. Gail in Florida, hi.
Hi, I just want to find out, if the moon is traveling away from the Earth at a very slow pace, but eventually it'll get away from the Earth, what happens to all the tides and people's cycles, menstrual cycles, the ebb and flow tides, and so on?
Yeah, lovely question. You're quite right, the moon is moving away from the Earth. It's doing it at the rate of a couple of centimetres or so every year. The reason it's doing that is because the moon travels around the Earth, taking a month to do it, but of course the Earth turns inside the moon. The Earth is rotating. The moon is exerting a gravitational attraction on the surface of the Earth, pulling water towards it. That's why you have a high tide on the side of the Earth close to the moon, because you have a bulge in the water there. You also get another bulge on the other side of the Earth as well, which is your other high tide. And because the Earth is turning inside the moon, that bulge is slightly ahead of the line of sight to the moon, which means the Earth is exerting what we call a torque, or applying a force to the moon, speeding it or giving it energy on its orbit, and this means it moves further away from the Earth, and in the process its orbit becomes longer. Now, when the Earth and the Moon were very young, so the Moon formed probably about 4.5 billion years ago, it was much closer into the Earth, and as a result we had much higher tides and shorter days, because the Earth was also spinning faster. The Earth has given some of its energy to the Moon, the Earth has slowed down a bit, so days have become longer, the Moon's moved further away, therefore tides take longer between tides, and they've got smaller. Taken to its logical conclusion, one day the Moon will disappear completely, and the Earth won't have any tides. Well, whether or not there'll be other consequences for our physiology is rather a moot point, because it'll take so long for that to happen that the Earth will probably have been eaten by the sun by then.
Okay, thank you very much, Gail. Hey, does that answer your question? Thank you. Let's go to Lerato in Randfontein. Hi.
Hi, Ria, how are you?
Fine, welcome.
Good. Hi, Chris. I want to ask you a quick question. I want to ask you, what makes people to lose weight when they are stressed?
Yeah, hi, good morning. I think probably there's a range of answers to this. If you look at what happens to people when they become stressed, they don't always lose weight. They also gain weight too in some cases. Some people have comfort eating. Some people actually just put on a lot of weight because they eat things like high-calorie foods and chocolates because they find them a comfort. So it's not always the case that people lose weight when they're stressed. Some people do. In other words, when you have emotional distress, it causes behavioural changes, and in some people, that behavioural change manifests as upset stomach. You get sort of abdominal pain or loss of appetite or feel sick, and this puts people off of wanting to eat. So some people lose weight, others seek refuge in the larder. So I don't think there's one single answer, but it's usually that it's an abdominal manifestation of emotional distress, which does this to people.
Yeah, absolutely. Which one are you, Lerato?
No, neither.
Okay.
What about Thomas then? Thomas must be critically stressed all the time. The amount of weight he doesn't put on, given how much he eats.
I don't think I've ever seen him stressed, actually. No, he does get stressed when we lose our connection to you in particular, and that's as far as it goes. Okay, let's go to, is it Gerard in Linwood? Hi.
Hi. I was just wondering, early in the morning, if I go to a shopping centre, I tend to get quite tired very quickly. And I was wondering if maybe the lighting or anything like that can cause you to become quite tired. Like sleepy, I get quite tired.
702 and Cape Talk.
The Naked Scientist.
That question. Did you get the question about, I think it was artificial lighting? That's what he wanted to ask, whether it makes you tired. That was the gist of it.
Well, it's a really good question, and the answer is yes, it can. And the reason for this is that the new generations of things like compact fluorescence and LED lighting, especially LED lighting, is that they've got a lot of blue light in them. And if people use these, especially laptop screens, which have them in the backlighting for the laptop screen, or your LCD television, if you're watching these screens late into the evening, or lighting your home with them, you're sending your brain a very strong wake-up signal, because the blue light is at roughly the right wavelength to activate a group of cells which are at the back of your eye, whose sole job it is to tell your brain it's bright sunlight, get up in the morning. Therefore, when you're trying to go to sleep at night, your brain has received a really potent shot in the arm wake-up signal, and so people tend to sleep poorly. If you don't sleep well, you will feel more tired the next day, and there is evidence that increased use and exposure to tablets, LCD, flat screens, and these sorts of bright lights late into the evening is affecting our physiology. And so scientists are now saying perhaps we need to design mood lighting where we change subtly the colour of the lights we're exposed to as the day goes on, with a very blue-dominated bright signal in the morning going through to a much softer, more red-dominated signal in the evening, which will make us feel sleepier and will therefore send us off to sleep, and we'll get a better night's sleep as a result.
Chris, just going back to the Ebola issue, we lost you at a point where you were talking about the origin. I mean, the question was about the animals and humans, and you were actually talking about the origin of Ebola. So many people wanting us to continue.
Yes, well, what people have discovered when they've done what we call trapping exercises, so in other words, you go to a place where there's been an outbreak of Ebola, and you trap all of the animals that move around an outbreak, because we don't think that big animals like chimpanzees, gorillas, great apes, we don't think they're natural hosts of Ebola because they die. Natural hosts of something just carry it and they don't get sick. Trapping exercises have reproducibly shown that bats and certain species of fruit bat are consistently found that carry antibodies against Ebola, proving that they must have been in contact with the virus at some point. And also they can even recover the genetic material of Ebola from these bats, proving that they are currently carrying and replicating, in other words, making copies of the virus in them all the time in those infected animals and not getting sick. And that's a sign of a good carrier. And so we think that the natural host of Ebola is these bats, and that what happens is that at certain points in time, the bats come into contact with other animals whether that's humans catching them as a delicacy, because in some parts of Africa, bats are part of the bushmeat trade. They're regarded as a food delicacy, so they get eaten. When people catch them and butcher them, the bodily fluids from the bat get onto the hunter's hands or into a cut, or in the kitchen they get into an abrasion on the skin, and this infects the human. And the human then amplifies the infecting dose manyfold and infects other people. Now, the question about the dog, because they destroyed the dog in Spain that was owned by the nurse who currently is in hospital with Ebola, having nursed the Spanish priests who were missionaries in Sierra Leone and who came back with Ebola. She caught it, we think, from looking after them, probably from a contaminated suit or something. There's no evidence her dog actually had Ebola. There's no evidence that the dog was in any time in contact with her when she was symptomatic. But there is evidence, if you look in dogs, you can find dogs have got antibodies against Ebola, which might suggest that dogs can get infected with Ebola. On the other hand, they might not. That might have just been exposure to Ebola material in the environment, because dogs go and eat dead things, rats, mice, bats, whatever they find. Doesn't mean they've been infected. They may have just become in contact with Ebola particles, and that could have led to them developing these antibodies. We don't therefore know whether dogs are an amplifying host in the same way a human is for Ebola. Those experiments have never been done, to my knowledge.
Well, Chris, we got through it somehow. Let's hope we never experience this again next week. Thank you.
Fingers crossed.
I suspect it's from our side, but thank you so much for your patience. And those of you whom we had to turn away, next week, I promise you, we'll do something.